Good afternoon, everyone. Let us start. Remember, we have learned about solar radiation and heat budget. Today, we shall discuss about temperature and factors affecting temperature distribution. Now, let me present my screen. Temperature. Now let us read what is meant by temperature, what is meant by heat. Let us find out the differences. See here, while heat represents the molecular moments of particles comprising a substance, temperature is the measurement in degrees how hot or cold a thing or a place is. Okay, so it means that heat refers to energy transferred into or out of an object because of temperature differences between that object and its surroundings. Okay, heat refers to the energy transferred into or out of an object. And whereas a temperature is a measure of the average kinetic energy of the atoms or molecules in a substance. Okay, see, when a substance gains energy, its particles move faster and temperature rises. By contrast, when energy is lost from a substance, the atoms and molecules vibrate more slowly and temperature drops. In short, humans think of temperature as how warm or cold an object is with respect to some standard measure. So this is the difference between the temperature and the heat. Okay, heat represents the energy and the temperature measures. Temperature is the measure. Okay, temperature is the measure how hot or cold an object is. So this is the main difference between heat and temperature. Okay, any question from your side regarding difference between heat and the temperature?
No, sir.
Okay, then next we have factors controlling temperature distribution. So temperature here at any place is influenced by latitude of the place, then altitude, that is the height of the place, distance from the sea, then air mass circulation, then presence of warm and cold ocean currents, and the fifth one, local aspects. So let us read in detail. The first important factor is the latitude. Okay, so temperature of a place depends on the insolation received. It has been explained earlier that the insolation varies according to the latitude, hence temperature also varies accordingly. Okay, in the previous lesson we have learned that this insolation, the amount of incoming solar radiation, varies from latitude to latitude, and that is why temperature also varies accordingly. So let us see one diagram. See here, latitude, okay, these are the horizontal lines. Okay, imagine lines drawn on the globe. Say for example, this is a latitude. Here we have equator, then this is 30 degree north. Likewise, we have 23.5 degree, that is tropical Cancer, and so on. Okay, and we have learned that, see, along the equator we find almost vertical rays of the sun here. Okay, vertical rays of the sun. And if we move away from the equator towards the pole, then this sun's rays is inclined. See here, this is a tangent, and the angle formed here is not 90 degree, that is less than 90 degree. And likewise here also it is more inclined. Okay, see, inclined rays, as we explained earlier, inclined rays, okay, see here, inclined rays spread a larger area, and hence heat is distributed over a greater area, and that is why we feel cold. This we have explained earlier. Okay, in the case of vertical rays, see, it is spread in a smaller area. That means heat is concentrated in a smaller area, and that is why we feel hot. And so likewise, see, in these polar areas also, since the solar radiation is inclined, see here, solar radiation is inclined, heat is distributed over a greater area. Just compare. Okay, just see here, let us consider that we are getting the same amount of energy. See here, and the same amount of energy obtained at the equator is also obtained at the polar region. However, since the inclined rays, okay, are spread over a greater area, as I told you, heat is distributed over a greater surface area, and that is why we feel cold. And because of this reason that say we find a high temperature along the equator, and temperature decreases as we move away from the equator towards the poles. And like that in the southern hemisphere also, as we move away from the equator, temperature decreases. So in this way, latitude affects the temperature of a place. Okay. And next we have this altitude, that is the height of a place from the sea level. Okay, temperature, the atmospheric temperature is indirectly heated by terrestrial radiation from below. This we learned earlier, okay, in the previous lesson. The atmosphere is indirectly heated by the terrestrial radiation from below, and therefore places near the sea level record higher temperature than the places situated at the higher elevation. In other words, the temperature generally decreases with increasing height. Okay, and the rate of decrease of temperature with height is termed as normal lapse rate, and it is 6.5 degrees Celsius per 1000 meter. Okay, see, altitude, we have known that altitude means height of a place. Okay, altitude means, say for example, this is a relief, and here we have sea. Okay, we have the sea level here, and altitude means height of a place from the sea level. So this is what I call altitude. And you know that this surface of the earth, okay, yesterday we learned that first the surface of the earth is heated by the sunlight, and the heated earth again radiates back long wave radiation, infrared radiation, and it is absorbed by the water vapor, then carbon dioxide and the other greenhouse gases. So in this way, atmosphere is indirectly heated by the earth's surface. That means, okay, that means the source of heat for the atmosphere is the earth's surface, and if we move away from the source of the heat, then temperature is decreased. Okay, so we have known that Earth's surface is the source of heat for the atmosphere, and if we move away from the source of the heat, then temperature is decreases at the rate of at the rate of 1 okay at the rate of this 1 degree Celsius for every 165 meters of this SN. Okay, let's see here. This is 1 degree Celsius for every 165 meters of SN. That means if you climb, okay, if you climb 165 meter from here, okay, from the sea level, if you climb 165 meters, then temperature will be decreased by 1 degree. Okay, that means if you climb up 1000 meter from the ground, then temperature will be decreased by this 6.5 or 6.4 degree Celsius. Okay, if you see this graph also, see at the sea level the temperature is around 20 degrees Celsius. Okay, and when we climb up a mountain, okay, or when we ascend towards the sky, so temperature is decreased. Just see the diagram. Okay, see here, this side represents altitude. We have the sea level here, then okay, so these are the altitude. So when we ascend towards the sky, so temperature is decreased. See here at 7 kilometers above the ground, temperature is minus 20 and so on. Okay, at about 14 kilometers from the surface, temperature is around minus 60. So in this way, temperature is decreased as we climb up a mountain, and that is why Zanbi Mao, okay, is colder than the Zanbi the Sisipur, because Zanbi Mao is higher in altitude than Churchandpur. Okay, then see, let us see another diagram. See here, as given here. Okay, just given here. Places near the sea level record higher temperature than the places situated at higher elevation. Okay, and in other words, temperature generally decrease with increasing height. So this one more explanation, okay, about it. Not, this is not the diagram. Okay, see here, near the surface, okay, near the surface, the gases which can absorb infrared radiation like water vapor, dust particles, and this carbon dioxide are concentrated near the low-lying areas, and these gases are thin, okay, on the top of the mountain. Air is rarefied, okay, we have less density of air at the top of high mountain as compared to the foothills, and that is why we feel cold at the top of the this mountain. Okay, so any question regarding this altitude as a factor? Remember, temperature decreases with increasing height at a rate of 1 degree Celsius for every 165 meters to ascend, and this rate is known as normal lapse rate. Okay, the rate of decrease of temperature with increasing height is known as normal lapse rate. So it is 6.5 degrees Celsius per 1000 meter, or 1 degree Celsius per 165 meters to ascend. Any question from your side?
No, sir.
Okay, next we have another factor, that is distance from the sea. So this is another factor that influences temperature. Okay, And see, compared to land, okay, compared to land, the sea gets heated slowly and loses heat slowly as compared to the land surface. Okay, the sea gets heated slowly and loses heat slowly. In other words, land heats up and cools down quickly. Okay, land surface heats up and cools down quickly, and therefore the variation in the temperature over the sea is less as compared to land, and the places situated near the sea come under the moderating influence of the sea and the land breezes, which moderate the temperature. Okay, now let us consider one diagram. See, this is the diagram which was opened earlier. Okay, and this diagram explains why this land heats up and cools down this quickly as compared to sea. In other words, why sea warms up and cools down slowly. So it is given here. See, over the lane, okay, over the lane, see, surface is opaque. Number one, surface is opaque means the sunlight cannot pass through into the soil, and that is why the insolation will be concentrated only in a very thin layer of the surface. Okay, so this is the sunlight insolation, and since the lane is compact, heat will be confined, okay, here. That means it can heat only a very thin layer, only these 15-20 centimeters. Okay, then here on the lane we have this less evaporation process. Okay, then one more thing is that since land is opaque, that sunlight cannot pass through, land has no mixing. Okay, see, land has no mixing between the layers. It is not mobile like water. At the same time, see, land has a lower specific heat. What do you mean by specific heat? Specific heat refers to the amount of heat energy required, okay, to raise the temperature of 1 gram of a substance by 1 degree Celsius. So it means that land requires less energy to raise its temperature, whereas water requires more energy to warm up. Okay, that means to raise the temperature of 1 gram of water will require more heat energy. Okay, so that is why land heats up and cool down quickly as compared to water. And as compared to land, sea, we know that water surface is transparent. Okay, light can pass through, insolation can be, okay, can reach up to the depth, up to this bottom, because water is transparent. That means the sunlight can pass through it, and since water is mobile and there will be mixing, okay, by movement, because water is mobile and it can move here and there, and because of that heat is distributed. And okay, and one more thing you have to know is that that as given here, the specific heat of water is higher than land. That means water requires more heat energy as compared to land. And do not forget, specific heat means the amount of energy, okay, required to raise the temperature of 1 gram of a substance by 1 degree Celsius. Specific heat of water is higher than land. That means water requires more heat energy to raise the temperature of 1 gram of water by 1 degree Celsius. And that is why water heats up and cools down slowly. Okay. And one more diagram, okay, is here. See here. places situated near the sea come under the moderating influence of the sea and the land breezes and moderate the temperature. Sea breezes, land breezes you have learned earlier. See here, this is the diagram showing this land breeze and the sea breeze. During the daytime, okay, a cool sea breeze is blowing towards the land, whereas in the night time this cool land breeze is blowing towards the sea. So in this way there is a exchange of warm air and a cool air during the daytime and the night time. And in this way, places located near the sea, okay, that is in the coastal area, have a moderating influence of the land breeze and the sea breeze. Okay, so that is the point mentioned here. And you must know that places very far away from the sea, okay, will see, for example, here this is a very big continent, and if a country is located here at the center of a continent, see, the moderating influence of the sea will not be there because it is located very far away from the sea. And that is why this country will be very hot during the summer and will be very cold during the winter. That means that this place will have extreme climate, that is very hot in the summer and very cold in the winter. And such condition is known as continentality. That is very hot in summer and very cold in the winter. That is, the temperature condition is extreme. And such type of situation is known as continentality. Okay, because the effect of sea is not there. The effect of sea breeze, land breeze is not there if a country is located very far away from the sea. Okay. Then any question from your side?
No, sir.
Okay, then another factor, the fourth one, air mass and the ocean currents. You know, air mass, actually it will be discussed in the next chapter, but CBSE has deleted for this session. So let me tell you what is air mass. Okay, air mass is a large body of this air having this uniform condition of temperature and humidity at a given level of altitude. Just see here, let us say this is a large land mass, and air mass is a very thick layer of air. Okay, so and here in an air mass, so temperature condition and the humidity condition remain the same. For example, this is isotherm. Okay, and so let us say temperature here is let us say 30, for example, 30 degree. Okay, 30 degrees Celsius. So, and here the humidity here is, let us say, 80%. So it means that in an air mass, okay, temperature here, and here remain the same. There is uniformity in the distribution of temperature, and humidity also remain the same. Humidity condition here remain the same. Okay, this is what we call air mass, and the size of air mass is very big. Okay, more than hundreds and thousands of kilometers. Okay, a square kilometer in size, and the thickness also more than 10 kilometers sometimes. Okay, and let us read. So this is about air mass, and like land in the sea breezes, the passes of air masses also affect the temperature. Remember, we have two types of air masses, warm air mass and cold air masses. Okay, and the places which come under the influence of warm air mass experience higher temperature, and the places that come under the influence of cold air mass experience low temperature. Okay, that is advection. Okay, I think you must be remembering this advection process. See here, see this is at air mass. Okay, maritime tropical warm air mass. Warm EMT means maritime tropical. Okay, maritime tropical warm air mass, and here this water vapor content specific humidity is 17 gram per kg. Okay, so when this warm air mass moves in this area, then temperature of this land mass will be increasing and there will be rainfall. Okay, like that, when maritime polar this air mass moves here, then temperature here will be lower because this is pole air mass. So in this way, air mass affects the temperature of a place when it moves. Okay, then similarly, places located on the coast where the warm ocean currents and the flow record higher temperature than the places located on the coast where cold currents flow. So ocean currents are streams. Okay, ocean currents are streams caused by this gravity difference, then wind friction, and water density variation. Just see, it is just like a river. Okay, just see here. See, let us suppose this is a big ocean, and in the ocean also we have this in one channel the water may be moving. Okay, here just like a river, in the oceans also the water moves under the influence of the under the influence of the wind or due to this gravity. And such type of movement of ocean water, just like a stream, is known as ocean currents. Okay, we have two types of ocean currents: warm ocean currents and the cold ocean currents. And like the air mass, okay, like the air mass, just see here, see this diagram here. Just see here. Okay, so this is a map showing ocean currents. See the color code. Okay, here this color code shows warm ocean currents, and this color code blue one shows cold currents. And just see here, when these warm ocean currents, when the warm ocean current hits this area, this coastal area, the western part of North America, so here this coastal area will be warm up, and there will be rainfall. And likewise other place, for example other place, okay, just see here in this case the western coast of Africa, here cold Benguela current is striking this area, and that is why this coastal area, okay, will be, the temperature of this area will be lowered and there may not be a rainfall. So in this way, ocean currents also affect the temperature of a place. As mentioned here, when these warm ocean currents flow, then it will record higher temperature, and when cold ocean currents flow nearby the coast, then temperature will be lowered and there may not be rainfall. In this way, ocean currents affect the temperature. Okay. Then the last important factor not explained here is the local aspects. This I have explained you many times. Okay, see here, local aspects means the direction of the slope. And here about this we have a diagram here. Okay, see, this is a mountain range, let us suppose, located in the northern hemisphere, and this is another mountain range located in the southern hemisphere, and these mountain ranges are running east-west direction. And because of that, see, the mountain range located in the northern hemisphere will get intense sunlight on the southern slope. Okay, see here, this side is the southern slope and this is the northern slope. And see, if you see this diagram, in the southern slope of the mountain located in northern hemisphere, the sun's rays are almost vertical here, and that is why we get intense sunlight. Whereas northern slope, it is inclined and heat is distributed over a greater area, and hence the northern slope is cooler than the southern slope. And contrary to this, okay, On the other hand, the mountain range located in the southern hemisphere sea, in this case, the northern slope of the mountain will get this vertical rays of the sun, and hence the intensity of insolation will be high, and higher temperature will be recorded as compared to the this southern slope. In the southern slope of the mountain, we get inclined rays of the sun, and temperature is low. That means we feel cool. Okay, we feel cooler as compared to the southern slope of the mountain. So in this way, the direction of slope also affects the distribution of temperature of a place. Okay, any question from your side?
No, sir.
Okay, then let us stop here for today. Don't forget to send your names in the WhatsApp group for attendance. Thank you very much for joining my class.